this angle, what I'm going to do is I'm going to redraw just that little section. And actually, I should probably use different color or the same colors. So the axis is going to be in white or gray, whatever that color is. And then we have the first part of our region of interest is the circle, right? And then it switches to the cardioid. Actually, let me finish drawing the circle. And when I draw this, I'm going to overemphasize certain things like the angle. All right, so this is the region of interest that we want right here. Now, what you should notice is that the boundary of those regions changes. What do I mean by that? Well, let's look at this. If I look at this line here, and I come to this intersection point there, one part of the region is actually here, and the other region is right there. Okay? So what that tells you is that because you have two different boundaries forming your region of interest, you have two different polar integrals. Okay? So this is going to be your R1. Oops, I forgot to get out of that mode. So this is R1. Oh, crap, you can't see that. Let's do a color you can see. Mauve. It's kind of feminine, but we'll deal with it. R1 and R2. Okay. So now for R1, what forms the boundary of our region of interest? Is it the blue or the red? Is it the cardioid or is it the circle? Let's look at our graphs again. You see the blue is the cardioid. So right here for R1, you see how we get the blue? It's the cardioid, right? So what we would have to do is integral from that intersection point, which we found to be 2 pi over 3, to pi. And 1 second. Because remember, I told you we're going to do symmetry. Can I call you back? Is it important? Is it important? I'm web tutoring. Can I call you back? Okay. I'll call you back here in a little bit. Bye. Sorry about that, guys. So we have 2 pi over 3 to pi because I told you I was going to use symmetry. So what I did was just, I went from here to there and stopped. So that's why I didn't write the 1/2 there, because technically there should be a 2 times 1/2 there. And that'll cancel. So here what we end up with is r squared, which is going to be the 2 minus 2 cosine theta squared. And then for R2, it's going to be from that beginning point of the circle to that intersection point. What is the beginning point? Where does that circle start to, at what angle, at what angle do you start drawing the circle? No. It's this line right here, 90 degrees, or pi over 2. Okay, if you were to find the horizontal tangents at the pole by taking the derivative, then you would, or the horizontal asymptotes, you would find that it's at pi over 2. So you'd go from pi over 2 here to pi, to the intersection point, which is 2 pi over 3. And what is the region of interest here? What forms our boundary? a circle now, right? So it's going to be negative 6 cosine squared. Now comes the integration of trig that a lot of people love. So how would I integrate the first one? Mm-hmm. It'd be 1 plus for cosine squared. You were just testing me, I know. Okay, and then at this point, you're going to get plus. We'll deal with that one here in a second. All right, so here you're right. Let's integrate the first two. You're going to get 4 theta, and then minus 2. What's the integral of cosine theta? Integral of cosine theta. Good. And then minus 2 times the integral. What did I tell you about that phone, buddy? I see. Then you're right, you do use that identity. So we're going to get, let's see if I can remember all that. It was 4 theta minus 2 sine theta, and then minus 2 integral of 1 plus cosine 2 theta over 2. Oops, not squared. Right? The 2's will cancel, and then you get 4 theta minus 2 sine theta, and then the integral of 1 is theta, and then what happens here? How do I integrate that? Mm-hmm. Most people can do it in their head. They realize that the constant will be divided out, but since this is an instructional video as well, I'd like to show the steps. So if you did the integral of cosine of u, and then you get du over 2, you can see that 1/2 would come out. And what's the integral of cosine? And then you plug back in what your u equaled. So that goes in there. And why is it minus? Because of this minus sign right here in front being distributed. Do I write plus c now? Why don't I write plus c? It's not a plus c because we have bounds, right? It's from 2 pi over 3 to pi over 3. So, no, 2 pi over 3 to, that's not right, to pi. So 2 pi over 3 should be on bottom because it's the smaller of the two angles. So here we're going to get 4 pi minus, what's the sign of pi? Zero minus pi. And then sine of 2 pi is what? Yes. Don't distrust your brain. It told you the answer for a reason. So many people have doubts. Doubts will get you in trouble. So plug in your theta. You're going to get 8 pi over 3 for the bottom one. What's sine of 2 pi over 3? Good. Is it positive or negative? Are you positive? Because you kind of hesitated. Okay, just making sure. And then what's sine of 4 pi over 3? Okay, so let's clean up house. We're going to get 3 pi for the first part. And then minus, let's see, let's just do that. Here we're going to get a 6 pi over 3. Alright, which is also 2 pi. And then here we got 2's canceling, and we got, oh, actually I'm going to leave them there because there's another root 3 over 2. Actually, that's over 4. So it's going to be, I will write it in. We'll do a common denominator. So then plus root 3 over 4. You don't want to skip any steps, too many sources of error. And then here we have common denominator would be 4 root 3 over 3, or 4, sorry. Root 3, 4. So it'd be 3 pi minus 2 pi. And then this is a minus 3 pi over 4, so it becomes a plus 3 pi over 4. Or, sorry, 3 root 3 over 4. So then 3 pi minus 2 pi is pi. 3 root 3 over 4. And then we combine that with the other answer, which we haven't even started on. So that would be 2 pi over 3 pi halves, which would be 36 cosine squared. We already know that cosine squared integral. We did that earlier, right? What did that equal? Theta minus 1. Let's just redo it. There's no. So that'd be 36 integral of 1 plus cosine 2 theta over 2, which then becomes 18 integral of 1 plus cosine 2 theta. So it becomes 18 theta plus 1/2 sine 2 theta over 2 between 2 pi over 3 and pi halves. Any questions? So then when you plug in, you're going to get 18 times pi over 2 plus, oop, no, I should have done the other one first, sorry. 2 pi over 3 plus sine of 4 pi over 3, which we already know is negative root 3 over 2. And then all that is going to be minus pi halves. Oops. Asking for trouble. Writing a 3 when I said 2. Sine of 2 theta over 2. Is that right? It's all starting to blur together. I've probably worked between 65 and 70 hours this week, guys. I know you didn't see me in my office one day this week, but I've been crunching out web tutoring and videos all day, every day, while trying to rest from being sick. Well, I started to get sick Tuesday morning, and then I felt a little bit better on Wednesday. Still had it on Thursday. Feel a lot better today. But every day, though, when I was supposed to be resting, I was, web tutoring or making videos. I'm surprised you haven't used this until today, Ibrahim, or Rahim. I've been calling you Ibrahim this whole time. I'm tired, buddy. I'm sorry. At least I got your last name right, you know. So here, when we simplify, we're going to get sine of pi goes to 0. So we have 18 distributed times all that's going to give me, let's see, 18, 6, 12 pi. 4, so we're going to be left with 2, 9 root 3 over 2. And then here we're going to get a minus 9 pi, is that right? 9 pi. So here, these two combine to give you 3 pi. So when I add 3 pi plus pi, I'm going to get a 4 pi. And then when I add 3 root 3 over 4 to this, I would need to make that a 18 and that a 4. So that would give me 21 root 3 over 4. So you can see it's pretty complex if they want it to be. Yeah. So hopefully when I simplify all that, I should get 7.85. Let's see if I do. I would hate to have made a silly mistake somewhere in between, but it happens. 4 times second pi. Where's my pi button? It's not my normal calculator. I'm sorry, gentlemen. There should be a pi button on here. It's got every freaking thing else. Are you kidding me? Where's pi? Ah, there it is. Why wouldn't it be over by the e's and logs? 4 pi gives you that. My plus 3 times square root of 3. Okay, you can be looking for another question if you want. Okay. What does that mean? Does that mean you're okay? Okay. I hope it's not because I said I was tired, buddy. I don't mind helping you. Okay. That's fine. Anytime, man. Hopefully we can use this more frequently. I've asked you to sign up on my schedule in front of my office door. I'm not sure why you haven't, but I'm available to you when you need it, okay? I'm just not going to go chasing you guys down. Okay? Good luck to you tonight, buddy. Bye-bye.